Hey guys, Mr. Lee here. I decided to stick around after everyone had left just to show you this demonstration on how you can take something that's just an oscillating frequency, like an extremely high frequency, and turn it into a linear graph. Okay, there are many types of signals that you can do in this fashion, but I use the mass airflow because the mass airflow is an extremely high frequency digital square wave. Okay, and if you recall, on this Buick, it's a 1990 something or other Buick Century. At idle, it's over 2,000 hertz, so 2.5 kilohertz, I believe, is what the spec was at idle, or something or other, right? So in 1 second, you have 2,000 plus oscillations, right? So I'm just gonna show you what it looks like with your multimeter first. If you do this measurement with your multimeter, there is a hertz function, as I explained to you earlier. Okay, I put it under hertz, right? The signal wire is the third wire, as you can see here, right? I just back probed it as if it was your TPS or whatever. It's just your signal output, except the output is not voltage. The output is in hertz, okay? Now what I'm gonna do is I'm gonna take the negative lead. I actually forgot to grab an alligator clamp for this. I'm gonna try to ground this so that I can just kind of let go. Okay, so it's grounded. Notice how it's 2,000 hertz, right? Now when I slap the throttle, okay, you can see that it is moving, but it's just way too slow to actually see the response. But you do see the kilohertz, right? But dynamically, it's very difficult for you to check it. Okay? Now, sorry, ignore the amp clamp's actually nothing, sorry. That was a failed experiment, let me get rid of that. So in the Pico, I'm gonna boot it up from scratch just to show you guys how it works. And you'll understand why I have two of them here in a moment. So ignore the amp clamp, I'm gonna disconnect the amp clamp for now, let's just pretend we can do that. So I'm gonna let the system boot up. It's very easily, actually. So just give it a minute, it'll start up and I'll show you. So remember, we just got the Pico basically. I got channel A. I used the wrong color, but I don't know where the blue one is, so it doesn't matter. Channel A. Positive end is hooked into that wire there. I couldn't jam two back probes in there. I just used the wire piercer. Okay, and then the black is to ground. Okay, very straightforward, right? Now, oh, I see you already got some kind of signal going there. So I'm gonna go to automotive measurements, and the reason why I could have set this up by myself, but I want to show you something here. I'm gonna go to automotive. I'm gonna go to sensors. You're gonna go to airflow meter. And when you go to digital, there's one very important note that you need to read about this. You know how it goes on the internet and then it brings you to the website? So once it loads the necessary PIDs to do what their recommended measurement was, I'll show you. Okay. So let it load. Okay. Blah, blah, blah. We hooked it up properly. One crucial thing right here. The frequency option available beginning with the Picoscope 4000 series. Okay? That means our 2-channel is a 3000 series. Our 4-channel is a 44 something or other. How did I find that out? I look at the back. Pico 4423. It won't work unless you have this. That's why we didn't see the frequency drop down earlier. So now that this is set up properly, let's go over here. Okay? We're just gonna go to, we'll just hit play. I'm gonna do this manually, alright? So I'm gonna hit play, it's gonna be a mess. I'm gonna turn off B. We don't need B, I'm gonna turn that off. Okay, so right now, A, I'm using an X1 probe, that's perfect. Voltage-wise, it's not voltage, we're doing frequency. So you're gonna go over here, you're gonna drop it down, and go to frequency. Actually, you know what, let me do volts first. I just wanna show you something. I wanna show you something quite interesting, okay? If you were using the older one, and you wanna do volts, okay? We're gonna do this pretty fast. We'll try 500 microseconds per division for a second. And I'm gonna hit 12 volt DC. I'm gonna hit play. Okay. There it is, sorry. So it's running. Anyway, so if I was to do volts, okay, let's say I was to do volts, all right? Let me make it even faster. Okay, that's a little bit too fast. So do that, and then we're gonna do more samples. Sorry, go to the left. 1 second here. Oh, okay, sorry. Here we go. So we got a trigger. I just said you could do single. Let's do single trigger. Over right here. Sorry, auto. That way it will repeat. We're gonna go voltage. I could leave it at 10. It doesn't really matter. DC. I'm gonna add a little bit more time, just to make it look more better. 500 microseconds per division. Sampling is 400 samples per second. You can make it even faster, right? It's up to you. It just makes it more precise, right? So this is essentially what your multimeter is looking at, the up and down frequency of the engine at idle. Now you can actually find out exactly how many frequency, like the actual kilohertz with the actual tester as well. With the picoscope. And how you do that is you go to measurements, you go add measurement to channel A, because that's the only thing hooked up right now. And when you go to the select type of measurement, notice how, look at all different types you can do here. Cycle time, DC, duty cycle, frequency. So we're gonna go frequency. You're gonna go okay. And if you look down here, that's your actual frequency, right? Min-max, automatically. Min-max, the capture count, the value. This is exactly what your multimeter is going to show you, but a heck of a lot faster, right? So if you did not have the Picoscope 4000 series, that's as far as you're going to go. Okay. Now, when you rev the engine, obviously I can't reach the car, but if you rev the engine, you'll see that the numbers respond very, very quickly. Now, I want to show you the actual graph too. Look what happens to the graph when I rev the engine. See how the oscillations come closer together, like I was trying to explain earlier? But still, that's a very difficult signal to plot against an output or like a desired, let's say, response. If you were to plot this mass airflow input against your oxygen sensor, just to see how fast your oxygen sensor responds to your mass airflow or your airflow ratio, air-fuel ratio sensor, this is very hard to gauge. So what you could do is, you go over here with the Pico 4000, see where it says DC and AC usually? Look at that, frequency, okay? You're gonna see that it's over voltage, somewhere up here somewhere, we can't even see it, it's over voltage. So you're gonna have to add hertz. I'm just gonna go to 20 kilohertz, as high as possible. Bring it down, nope, where is it? Give me a second. Is it the highest? What does auto do? Where is it? Hold on a second. What's my time here? Oh, that's right. We gotta make it slower. We just gotta make it slower. There we go. It was too fast. Basically, under the microseconds, that little notch there would have taken out the whole computer screen. So first off, I just want to turn off the trigger. I don't need a trigger. Okay, I want to make it even a little bit more time. Slow it down. We'll try 1 second per division first. Ignore all of this nonsense. That's actually just noise. I'm going to activate filtering. And just like your O2 sensor, you'll see that it will actually clear itself up. Now, you know what, better yet, let me add even more time, and then I'll adjust it after. Okay, so check this out, okay? Watch this. Okay, so you see that? Now, here comes the magic. I'm gonna pause it. I'm gonna activate filtering. I'm gonna drop all this noise off. There you go. There's your, see, you gotta be careful though. You see how I made everything nice and smooth? Like sometimes you don't wanna filter too much because some of this is valuable information too. These unstable peaks and stuff like that, right? I would probably see at that point, not really telling me anything. I would say I would probably do that. That's how I would analyze my signal. This looks all nice and pretty, but you lost a lot of information, as you can see, right? But I would maybe do something like where the peaks don't really do anything else but get large, right? So maybe about there. But as you can see, that's frequency over time, right? Let me close this off actually. That's frequency over time. Every time I snap my throttle, you see that rising linear graph, which is easier for you to visualize. Underneath, I would probably plot, let's say, like an air-free ratio sensor or an O2 sensor. So when I feel the snap in throttle, let's say I have like a fuel trim issue or something like that, this way I can actually compare the response time of all my input sensors against my all my basic reaction sensors, right? Your O2 sensor, your fuel trim, all that, even my injector pulse width, how quickly that changes, right? All of that stuff I can plot out over time, so I can see how long it takes for all of that stuff to happen the moment I snap the throttle. And the actual mass airflow is your first information gatherer for the computer to determine how much air is going in, right? So that's how you do it. Okay, so I'll let you guys try when you get into class, and it's a heck of a lot more detailed than using a multimeter, as you could see. Okay?